Today we're in activity 6.4, operations with complex numbers. When operating with complex numbers involving I, combine like terms by treating I as a variable even though it is a constant. All right, teacher's going to work 1a, so let's do that. So I'm going to put a 1 in front of here, 1 in front of here. So we multiply by 1, that's 3 plus 2i. Now we're multiplying by negative 1, so minus 1 plus 6i. We combine terms, so 3 minus 1 is 2. 2i plus 6i is plus 8i. Okay? Let's take a look at C. 5i times 3 is 15i. 5i times negative 2 is negative 10 times I squared. Okay? Now, I squared is equivalent to negative 1. So I'm going to change that to negative 1. So then that's 15i. Negatives are positives, so plus 10. Okay? And let's take a look at D. We use 4, so 5 times 2 is 10. 5 times negative 3 is minus 15i. 3i times 2 is plus 6i. 3 times negative 3i is minus 9 times I squared. Now, remember, I squared is negative 1. So that is negative 1. So I have 10, negative 9. Well, let's just do this. 10. Negative 15i plus 6i is minus 9i. Negative 9 times negative 1 is plus 9. 10 plus 9 is 19, so we have 19 minus 9i. All right? Now, the student's going to work 1b, 2a, 2b, 2c, and 2d. So go ahead and do that. And then E says, what do you notice about each product? Each product is a real number. Each number has no imaginary part. All right, let's take a look at the next page. All right. Ignore this page. All right. Consider each quadratic function. Okay. Use technology to scratch each graph on the coordinate plane. Okay. So I'm going to graph this in green, this in yellow, and then this in pink. All right, let's use Desmos to get those points. So let's do x squared plus 9. So graphing calculator, x squared plus 9. Now I don't see the graph, so I'm going to zoom out. And I'm going to pick points. 0, 9 is a good point. And then I'm going to scroll the graph, see if I can find a good point. 213. So I'm going to use that point. So 0, 9 and 2, 13. Now, if I go up 1, 2, 3, 4, 5, 6 to the right, then I have to go up 6 to the left 2. Okay, so there's this graph. And let's take a look at parentheses x minus 2 squared plus 1. Okay, it looks like I have a good point here and here. So I'm going to graph 0, 5 and 2, 1. Now, if I go up 1, 2, 3, 4 to the left 2, I have to go up 4 to the right 2. Excuse me. All right, let's take a look at the last graph. All right, let's see what we got here. 1, 1, 0, 2. Good, we can use those. So 0, 2. And then 1, 1. Okay. Now, if I go up 1 to the left one, I have to go up 1 to the right one. Okay. And then, all right, there's the graphs. All right. What do the solutions of the three functions have in common? Each function has imaginary roots because none of them have x-intercepts. Consider the function f of x equals x squared plus 9. Describe the structure of the function. How does it compare to the function u of x equals x squared minus 9? F of x equals x squared plus 9 is the sum of two squares, x times x plus 3 times 3. F of x equals x squared minus 9 is the difference of two squares, x times x minus 3 times 3. All right, go ahead and finish it up. Consider an equation written in the form ax squared plus c equals 0. Complete the table to show whether when the solution of a function are real or imaginary. When c is positive and when c is negative. So it's imaginary, real, real, and imaginary. All right, go ahead and fill that in. And let's take a look at the next page. All right. If the factored form of a difference of squares is a squared minus b squared equals a minus b, parentheses a plus b, what is the factored form of the sum of the squares? Okay. So a squared plus b squared equals, and this, I'm going to show you how to get this and this. So a times a is a squared. A times negative b is negative a b. B times a is ab. And then b times negative b is negative b squared. Well, ab minus b cancels, so you're left with a squared minus b squared. So that's why a squared minus b squared equals a minus b times a plus b. Okay. Now let's find out why a squared plus b squared is equal to this. Okay. So a times a is a squared. A times bi is abi. Negative bi times a is negative bi, abi. Negative b times negative b is negative b squared. I times I is I squared. So you have a squared. This cancels. You're left with minus b squared, but times I squared is negative 1. So you're left with a squared plus b squared. So this is why a squared plus b squared equals a plus bi times a minus bi. All right, let's take a look at D. What are the solutions to f of x equals x squared plus 9? So let's solve this. So we subtract 9 from both sides. You get x squared equals negative 9. Take the square root of both sides. Remember, square root's plus or minus. That cancels. You're left with x equals plus or minus the square root of negative 9. Now, the square root of 9 is 3, but because it's negative, it's 3i. So x equals plus or minus 3i. So x equals 3i and x equals negative 3i. Okay, go ahead and finish that up. All right, consider the function g of x equals x minus 2 squared plus 1. What is the solution to x minus 2 squared plus 1? So to solve, we're going to subtract 1 from both sides. I'm going to add line to our work. So that cancels. You're left with x minus 2 squared equals negative 1. We're going to take the square root of both sides. Remember, square root is plus or minus. The square root cancels the squared. You're left with x minus 2 equals, now the square root of negative 1 is plus or minus 1i. Now we're going to add 2 to both sides. So x equals, and let's go ahead and put the 2 in front. So 2 plus or minus 1i. Okay, go ahead and finish it up. All right. Consider the functions f of x equals x squared minus 2x plus 1, g of x equals x squared minus 3x plus 1, and h of x equals x squared minus 2x plus 2. And we want to remember that the discriminant is equal to b squared minus 4ac. One solution is b squared minus 4ac is equal to 0. Two solutions when b squared minus 4ac is greater than 0. And imaginary solutions are when b squared minus 4a times c is less than 0. So let's do the discriminant for f of x. So this is a, this is b, this is c. So that would be negative 2 squared minus 4 times 1 times 1, which equals 4 minus 4, which equals 0, meaning there is one solution. Okay, now let's take a look at g of x. This is a, this is b, this is c. So negative 3 squared minus 4 times 1, which equals 9 minus 4, which equals 5. Well, 5 is greater than 0, so there's two solutions. Okay, last one. This is A, this is B, this is C. So negative 2 squared minus 4 times 1 times 2, which equals 4 minus 8, which equals negative 4. Well, negative 4 is less than 0, so it's imaginary solutions. All right, so go ahead and finish up writing that. All right, let's take a look at the next page. All right, what is the solution to x squared minus 2x plus 2 equals 0? So this is A, this is B, this is C. We're going to plug these numbers into the quadratic formula. So x equals negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 2 divided by 2 times 1. All right, so let's simplify that. Negative times negative is positive 2 plus or minus the square root. Let's go ahead and do what's underneath the square root in the calculator. So I believe I can just use the graph to do that. So parentheses negative 2 squared minus 4 times 1 times 2, which is negative 4, divided by 2. All right, so now let's simplify that. That's 2 divided by 2 plus or minus. Now the square root of negative 4 is 2i divided by 2. 2 divided by 2 is 1, so you get 1 plus or minus I. All right, go ahead and finish up C. All right, you can apply the distributive property to determine whether an equation in factor form is equivalent to an equation in general form. You're welcome to read the worked example. Let's take a look at here. Recall that a quadratic function in factored form is written in the form of y equals a, parentheses x minus r1, parentheses x minus r2. Okay, use your answer to question 5 part C to write the form of the function. So R1 equals 1 plus I, and R2 equals 1 minus I. So we're going to plug these into this formula. So Y equals 1, parentheses X, minus 1 plus I, parentheses X, minus 1 minus I. So Y equals 1, parentheses X, minus 1 minus I, parentheses X, minus 1 plus I. Okay? All right, we're not going to worry about this question. Let's move on to the next. All right, student's going to work A, B, 8A, 8B, 8C using the quadratic formula. All right, student's going to work number 1. We're going to ignore this page. And the student's going to work 1, 2, 3, 4, 5, 6, and 7 with the help from Mr. Luke. Please use that help. Okay. All right. And then the student's going to work 1A, 1B, 1C, and 1D. All right, let's take a look at the next page. We're going to skip this section, and then student works 1A, 1B, 2A, 3A, and 3B. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.